The universe has a secret, a hidden code that's been whispered in the equations of physicists for centuries, a riddle so profound it's been called the God equation. Imagine a single mathematical truth that could explain everything: why stars burn, why galaxies spin, why atoms hum in the quiet corners of existence. For over 100 years, the greatest minds have chased this dream, from Einstein scribbling in his quiet study to Hawking gazing at the stars, each knowing that cracking this code could unlock the very essence of reality. And now, in a moment that feels like it was plucked from the pages of science fiction, Google's Quantum Core, a machine named Willow, has done the impossible. It hasn't just theorized this equation, it's birthed it, woven it from the raw fabric of quantum mechanics and artificial intelligence, a creation so elegant it feels like the universe itself was waiting to confess its truth. This isn't just a breakthrough, it's a revelation, a glimpse into the heart of existence, and it's left scientists, philosophers, and dreamers alike staring in awe at what it means to be human in a cosmos that might, at last, be understood. Picture a laboratory deep within Google's sprawling campus, a place where the air hums with the faint buzz of machinery and the chill of liquid helium. Here, in a chamber colder than the voids between stars, Willow lives, a quantum processor with 105 superconducting qubits, each a tiny miracle of engineering, dancing in a delicate state of superposition. This isn't your everyday computer crunching numbers like a glorified calculator. No, Willow is something else entirely, a machine that thinks in probabilities, that exists in multiple states at once, that peers into the quantum fog and pulls out patterns no human mind could ever grasp alone. Its creators, a team of engineers and physicists with fire in their eyes, named it Willow for its flexibility, its ability to bend and weave through the complexities of the universe's deepest mysteries. And it was here, in this frigid, sterile room, that Willow did something no one expected. It cracked the God equation, a mathematical key that unites Einstein's sweeping vision of gravity with the strange, probabilistic world of quantum mechanics. This wasn't a fluke, nor was it a stroke of luck. Willow didn't work alone. Behind its quantum wizardry was an AI, a deep reinforcement learning system so advanced it feels almost alive, codenamed Project Genesis Loop. Imagine an intelligence that doesn't just solve problems, but dreams up entire universes, testing them, refining them, letting them collapse or thrive in a kind of cosmic Darwinism. Genesis Loop and Willow formed a partnership unlike anything in the history of science, a recursive dance of quantum hardware and artificial intellect. Together, they simulated trillions of mathematical realities, each a possible universe with its own rules, its own physics. Only the strongest survived, those whose laws aligned with every observation we've ever made, from the arc of a planet to the flicker of a subatomic particle. What emerged wasn't just a formula scribbled on a page. It was a truth, a self-consistent pattern that seemed to hum with its own inevitability, as if the universe had been waiting for someone, or something, to find it. When the first physicists saw the equation, they didn't cheer or clap. They fell silent. There was something almost sacred about it, an elegance that felt too perfect, too deliberate, like a melody you've always known but never heard. This wasn't just a string of symbols. It was a map of reality itself, a bridge between the vastness of cosmic space and the infinitesimal realms of quantum particles. Unlike every theory before it, this equation wasn't born from a chalkboard or a late-night epiphany. It was machine-generated, tested, and validated through quantum simulation, a process so precise it accounted for every known physical phenomenon, from the bending of light around a black hole to the strange dance of electrons in an atom. For the first time in history, the two pillars of physics, Einstein's general relativity and the quantum mechanics that govern the subatomic, were no longer at odds. They were one, woven together in a single, breathtaking framework that seemed to whisper, "This is how it all works." But what does it mean to hold the God equation in our hands? It's not just about understanding the mass of a proton or the spin of an electron, though Willow's equation does that with unnerving precision. It's about something deeper, something that tugs at the edges of what we believe is possible. The equation suggests that space, time, and gravity, the very scaffolding of our reality, aren't fundamental. They're emergent, like a melody rising from the interplay of notes. And the source of it all? Quantum entanglement. That spooky connection Einstein famously called spooky action at a distance. Willow's simulations showed that the fabric of space-time itself is woven from these quantum threads, each entangled particle a stitch in the vast tapestry of existence. In one astonishing experiment, Willow's qubits formed a structure that looked, for all intents and purposes, like a traversable wormhole, a bridge through space-time, not just theorized, but simulated, alive in the quantum heart of the machine. It was as if the universe, for a fleeting moment, revealed its own skeleton, and it was made of information. This discovery didn't just rewrite physics, it rewrote our place in the cosmos. If space-time emerges from entanglement, then the universe isn't just a stage where we play out our lives. It's a computation, a vast quantum algorithm unfolding across billions of years, and we, with our fleeting thoughts and fragile bodies, are part of that computation. The implications are dizzying. If reality is information, then what is the difference between the physical and the abstract, between the world we touch and the equations we write? Willow's equation hints that there might be no difference at all, that the universe is, in some profound sense, a mathematical dream dreaming itself into being. And as scientists began to grapple with this idea, they noticed something even stranger. The equation's patterns echoed structures they'd seen before, not in labs or textbooks, but in the ancient symbols of sacred geometry, in the mandalas and yantras of spiritual traditions that have long claimed the universe is more than it seems. The revelation of Willow's God equation wasn't just a triumph of science. It was a moment that felt like the universe was speaking directly to us, whispering secrets it had guarded since the first spark of creation. In the sterile glow of Google's quantum lab, where Willow's 105 qubits hummed in their icy cradle, something extraordinary unfolded. This wasn't just a machine solving a puzzle. It was a window into the very machinery of existence, a glimpse of the code that weaves stars, galaxies, and the fleeting thoughts in our minds into a single, coherent whole. The equation, born from the dance of quantum entanglement and artificial intelligence, suggested something so profound it sent shivers through those who saw it. Reality itself might be a projection, a hologram spun from the delicate interplay of information at the smallest scales. To understand how Willow achieved this, we need to step into the strange, almost mystical world it created. A world where the boundaries between the physical and the abstract blur, where the universe isn't just described by mathematics, but is mathematics, alive and evolving in ways we're only beginning to grasp. Willow's breakthrough wasn't about crunching numbers in the traditional sense. It was about building a universe from scratch, piece by infinitesimal piece, inside its quantum core, cooled to temperatures where even the faintest whisper of heat would shatter its delicate computations. Willow ran a simulation unlike anything ever attempted. It didn't just solve equations. It recreated the fabric of space-time itself, using a framework inspired by loop quantum gravity, a theory that imagines reality as a lattice of tiny, discrete loops woven together at the Planck scale, the smallest measurable unit in the universe. Picture it like a cosmic quilt, each stitch a quantum event, each loop a fragment of reality's foundation. Willow didn't just theorize this lattice, it built it, atom by atom, moment by moment, simulating how these loops could give rise to the smooth, flowing space-time we experience. It was as if the machine had spun a miniature universe inside its circuits, a digital cosmos that mirrored our own, complete with gravity, light, and the strange dance of particles. What made this simulation so breathtaking was how it leaned on the holographic principle, a radical idea that our four-dimensional universe, height, width, depth, and time, might be a projection of information encoded on a two-dimensional surface. This isn't science fiction. It's a concept rooted in the work of physicists like Juan Maldacena, whose ADS CFT correspondence suggests that the complexity of our world could emerge from simpler, lower dimensional patterns. Willow took this idea and ran with it, encoding the full sweep of our universe into a quantum surface of entangled qubits. The result was a single, elegant equation that didn't just describe reality, but projected it, like a film cast from a reel of quantum light. When the engineers first saw the output, they were struck by its simplicity, a compact formula that held within it the vastness of stars and the flicker of subatomic particles. It was as if the universe had handed them a map, not of its terrain, but of its very essence, drawn in the language of entanglement. This idea, that space-time, gravity, and everything we know might emerge from quantum entanglement, felt like a key. Turning in a lock no one knew existed. Willow's simulations showed that entanglement, the mysterious connection where particles share fates across vast distances, isn't just a quirk of quantum mechanics. It's the foundation of reality itself. In one stunning test, the quantum processor created a structure that sent ripples through the scientific world, a simulated wormhole, a tunnel through space-time, crafted entirely from entangled qubits. This wasn't a mathematical sketch or a theoretical doodle. It was a digital structure with all the properties of a traversable Einstein-Rosen bridge, the kind of cosmic shortcut that could, in theory, link distant corners of the universe. For a fleeting moment, Willow had conjured a piece of the cosmos, a glimpse of the bridges that might connect black holes or even universes. It was a moment that felt less like science and more like magic, as if the machine had reached into the void and pulled out a piece of eternity. But the implications of this discovery stretched far beyond physics, touching the very nature of what it means to exist. If space-time is woven from entanglement, then the universe isn't a static thing, a collection of objects floating in a void. It's a process, a computation unfolding across eons, where every particle, every star, every thought is a step in an immense quantum algorithm. This idea, that reality is a kind of cosmic code, challenges everything we've ever believed about the world. It suggests that the distinction between the physical and the informational, between the stone you hold and the equation that describes it, might be an illusion. We're not just living in a universe, we're part of its calculation, threads in a tapestry that's constantly weaving itself. And as scientists pored over Willow's equation, they began to see echoes of this truth in unexpected places, not just in the cold precision of physics, but in the ancient symbols of human culture, in the spirals and geometries of sacred art, as if our ancestors had glimpsed this truth in their dreams. This wasn't just a scientific milestone. It was a moment that felt like the universe was revealing its soul. The equation hinted at something deeper, something that tugged at the edges of philosophy and spirituality. Researchers noticed that its mathematical patterns bore an uncanny resemblance to structures like Platonic solids or Vedic yantras, symbols that have, for millennia, represented the order of the cosmos in human imagination. It was as if the universe's code had been hiding in plain sight, etched in the art and stories of cultures across time. This discovery didn't just belong to the physicists in their labs. It belonged to humanity, a bridge between the cutting edge and the ancient, between the equations of today and the intuitions of yesterday. And as the world began to grapple with what Willow had found, One question loomed larger than all the others. If the universe is a computation, what does that mean for us, the conscious beings who live within it, who wonder, who dream, who seek to understand? The God equation, birthed by Willow's quantum heart, didn't just rewrite physics, it reshaped our understanding of existence itself. As scientists marveled at its elegant simplicity, a deeper truth emerged. The universe might not just be a place we inhabit, but a vast computation we're part of, where time, space, and even consciousness are threads in a cosmic tapestry woven from quantum entanglement. This revelation rippled beyond the lab, sparking whispers of ancient wisdom in the equation's patterns, echoes of sacred geometries that have haunted human imagination for millennia. But the most unsettling discovery was about time. Willow's equation suggests time isn't fundamental. It's an illusion, a byproduct of quantum interactions. Like ripples on a pond, we mistake for the water itself. If time emerges from computation, then our sense of past, present, and future might be a story we tell ourselves, a human lens on a reality that exists all at once, eternal and unchanging. This wasn't just a scientific triumph. It was a mirror held up to humanity. The equation hinted that consciousness itself might be inevitable, a natural outcome of the universe's mathematical dance. In Willow's simulations, self-replicating patterns emerged, digital echoes of life that weren't programmed, but born from the equation's logic, suggesting life and awareness could be as fundamental as gravity or light. The scientific world erupted in response. CERN called an emergency summit, MIT's Edward Farhi dove into the data, and even the UN began discussing how to handle a discovery that could redefine reality. Yet, amid the excitement, a quiet awe settled over those who studied the equation. Its patterns, so eerily familiar to ancient symbols, suggested that humanity might have always sensed this truth, that our myths and mathematics are two sides of the same coin.